Okay. Uh, a valuable antique chest is to be delivered onto a truck. The weight of the chest is 1,400 newtons. To get the chest from the ground onto the truck, the bed to the truck bed, which is 1 meter higher, the movers must decide what to do. Should they fit it? Should they lift it straight up, or should they push it up their 4 meter long ramp? Assume they push the chest on a wheeled dolly, which is simplified model is equivalent to sliding it up a frictionless ramp. Find A, the work done by the movers on the chest if they lift it straight up 1 meter at a constant speed. B, find the work done by the movers on the chest if they slide the chest up 4 meter long frictionless ramp at a constant speed by pushing parallel to the ramp. And C, find the work done by gravity on the chest in each case. And then D, find the work done by the normal force of the ramp on the chest. Assume all forces are constant. Okay, so in order to calculate work, we must calculate the force exerted by the forces. So I drew the force body diagram to help me calculate the forces and account for all of them. So the ramp is a simple machine, and this means that it can reduce the amount of work that must be done. So before this problem, I kind of expected that the work done by the movers is going to be the same no matter which way they do it in each cases. So we expect the work done by the gravity to be negative in both cases since the chest is moving up and gravity does pull down. And the normal force is to the ramp is going to be perpendicular to the displacement. So it does zero work on the chest because the perpendicular force does not do work. Since more than one force does do work on the chest, used subscripts like F prime to clarify which work is being calculated. And the first thing I did was I drew my my knowns of what I'd known, and that is that the weight of the chest mg is going to be equal to 1,400 newtons. The length of the ramp is d is equal to 4.0 meters, and the height of the ramp is equal to h, which is 1.0 meters. What I'm left to find is the unknown, is the work done by the movers on the chest, which is W sub m, and then the work done by gravity on the chest which is labeled as W sub g, and then the work done by the normal force, which is on the chest, which is W sub n. So now the displacement is 1 meter straight up. So the movers must exert enough upper force and equal magnitude to the weight of the chest to move it at a constant speed. So the work done is going to be equal to this equation here, which is going to be W sub m is equal to F sub m times change in R cosine theta, which equals to 1,400 newtons times 1.0 meters times cosine of 0, and that is equal to 1,400 joules. Now, this is where theta is equal to 0 because of the force vectors sub m and the change in R are in the same direction, yeah. And they're both in the same upward direction, that's right. So then we move on to part B right here, which I showed the sketch of the situation right here. I was able to text the X is along the incline ramp, and the y-axis is perpendicular to it, and the gravitational into its x and y components. Let's see. And then I drew the force body diagram right here to show the forces acting on it, with F sub m going up and mg going down. This is one where they're sliding along at a constant speed. The chest acceleration has to be 0, so that the x So the x subponent acts in the negative direction, and f prime sub m acts in the positive x direction. So from here, I use this equation right here. That's right. So you do sum of the force in the x direction is equal to x prime sub m minus mg sine theta is equal to 0. So then, from the right triangle formula of the truck, from the ramp to the ground, I was able to get this equation here, which is sine theta is equal to the height of the truck bed divided by the distance along the ramp, which is, put down simpler into h divided by d. Now that I have this formula, the f prime sub m, which is going to be equal to this equation here, which is mg equal times sine theta, which is equal to mgh divided by d. So this is the force and displacement are in the same direction. So theta is equal to 0 again, and I was able to get to the equation here, which is w sub m, which is equal to f prime m times d times cosine of 0, and it's equal to mgh divided by d. And then we're going to times d times 1, which is equal to mgh, which is equal to a positive 1400 joules. So just as we expected at the start of this problem, it's the work done by the movers is the same as part A. So now, in both cases, we're going to move on to C. And the force of gravity has mg and x downward. So now I chose the x-y axis, so now that it points upwards, it gives us fgy is equal to negative mg. And both cases, the deponent of the displaces along the y-axis is the change in y is equal to h, which is equal to 1.0 meters. So now we're going to do work done by gravity is the same for both cases. And then I was able to use this force W sub g, which is equal to F sub g y times the change in y is equal to negative mg times change in y, and that gave me, I plugged in my values and it gave me negative 1400 joules. So now I can move on to part D. So part D is to do this we got to have the normal force of the ramp of the chest does no work because it acts in a direction perpendicular to the displacement of the chest. So I get this formula here, which is W sub n was equal to n times the change in R times cosine 90 degrees, and it's equals to 0.